finally. There we go. So section 8.4 is going to go over some fancy trigonometric substitutions for integrals that have these different kinds of radicals in them. And based on what you're facing, you're going to make certain substitutions. And magically, I do mean magically, your integrand is all of a sudden going to be something that you can integrate. So we'll start with problem number 6, which looks like this. And I mean, you could try playing around. There's no u substitution that's going to work here. Hopefully nobody rewrites it as 4 minus x. Look, you can't take the square root like that. So then you start thinking about this new technique introduced in section 8.4 of a trigonometric substitution. So take a look at this, and let's see if we can't match it up with one of these. So which substitution am I going to use? 1, 2, or 3? Well, yeah, 1. Certainly you can look 2, right? Because it's not a plus. Now the difference here is what's first and what's second. Here you have the constant first and the variable second. Here it's the other way around. In our particular problem, this is the way we have it. We have a 16 minus x squared. So let's make our substitution that way. So the substitution we're going to make is going to be, let this x equal a. Well, what do I square to get the 16? 4. So it's going to be 4 times the sine of theta. Now we're just going to go ahead and plow through with the substitution a little bit. Dx. What's dx going to equal if x is equal to 4 sine theta? 4 cosine theta d theta. So 4 cosine theta d theta. You know, we should probably do one more thing here. Yeah, question first?
Yeah, like, how do you get the sine? I know you did the substitution, but was it like 1 over, like...
We get it based off of the form of the square root here. So we're kind of ignoring the rest of that. We're just saying, all right, well, let's just look at this. And that was your 4 squared, and this is your u squared. So no, it doesn't go back to that at all. It goes back to the substitutions that are right here on page 533. So your u, in our case it's an x, equals 4 sine of theta.
Okay, it just confused me because I wanted to put 1 over sine of theta.
Okay, all right, I understand. Let's do something else, and it's kind of a double check of our work here. And it goes back to your work with trigonometry a little bit. Let's create a triangle that reflects this kind of relationship. Because if you do, the one thing that you should see is a radical term like this. That should be part of your integral. Or you'll see it in our triangle. So for my triangle, let me rearrange this as x divided by 4 equals sine of theta. Okay. Let's draw ourselves a triangle. And let's remind ourselves of something that we probably haven't had to think about in quite a while. SOHCAHTOA. What's SOHCAHTOA all about? Yeah. All right, we're going to have to practice that together. Ready? 1, 2. All right, I'm kidding about that part. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So let's call this theta. Now these relationships only work if you have a right triangle. Don't try this at home or elsewhere if this isn't a right triangle. because things like opposite, adjacent, and hypotenuse don't really make sense or exist outside of a right triangle. So sine is the opposite over the hypotenuse. So that makes the opposite side x, the hypotenuse side of 4. Question is, what's the length of that side going to be? Yeah. Now let's tell you what, let's just put a variable here and then solve for it to show you that we get this. I mean, some of you can already see it, and that's great. If you can see it already, that's great. But you're going to get a squared plus x squared equals 4 squared. So a squared equals 16 minus x squared, solving for a. We'll take the positive root. We get a equals square root of 16 minus x squared. So that's kind of reassuring. That's telling us that we picked the right substitution. We had 3 to choose from. We got the right one because this term matches that one. All right, so a lot of substitution and simplification that comes next. X is 4 sine of theta, so that's going to be 4 sine of theta squared. Let's see, what else? This is going to be 16 minus 4 sine of theta squared. And last but not least, dx gets replaced by 4 cosine of theta d theta. So 4 cosine of theta d theta. So, wow. It's going to be a lot of simplification we do before we can start to unravel this some more. 4 times 4 is 16. So it's going to be 16 cosine of theta d theta over 16 sine squared of theta minus the square root. And now I don't want to take all day simplifying this, so let me try and speed it up a little bit. This is going to be 16, well, I don't know, maybe I will take a little bit longer. 16 minus 16 sine squared of theta. One thing that can simplify right away, we can cancel out the 16s. Okay, nothing big there. What else can I do? Yep. So this is going to be cosine of theta d theta times sine squared of theta times the square root of 16 times the square root of 1 minus sine squared of theta This is cosine squared. And what's the square root of cosine squared? Cosine. So let's take a look at what we're going to get here. It's going to be cosine of theta, sine squared of theta times 4 times cosine of theta, and then there's still a d theta up here.
Where does that 1 come from?
You factored out the 16. So it's 16 times 1 minus sine squared of theta.
So then why would you pull the 16, square root of 16 out by itself?
Because 1 minus sine squared of theta gives you cosine squared of theta. So this is the square root of cosine squared of theta, and the square root of cosine squared of theta is just cosine of theta. So that allows me to pull out my favorite Zorro pen and go, ole, and cancel that out. Cosine of theta is gone. So that leaves me with d theta over sine squared of theta. And then there's a 1/4 that I'll factor out in front. And it's looking better. Not better. Does anyone remember what the reciprocal of sine is? cosecant. Really, the cosecant squared of theta. Yes, thank you, d theta. Now, cosecant of theta, we don't use that one as much as we do secant of theta, but does anyone happen to remember what this integrates to? Very good. Negative cotangent. So I'll put the negative out front, 1/4, cotangent of theta. Let's not forget that all-important constant, plus c. Don't relax yet. Don't relax. Take a look back at our original integral. Our original integral was in terms of what? X. This has nothing to do with x right now, right? We need to come up with an expression that involves x. So, trying to think what might be a friendly way to do it. Cotangent of theta. Well, maybe I like it this way better. 1 over the tangent of theta plus a constant. Remember that triangle we drew way in the beginning of this problem? Let's go back and take a look at what the tangent of theta is going to equal. Now, I reworked it so that we were using the tangent, that we can use some familiar ones here. Tangent of theta is the opposite over the adjacent. So, what's the opposite? X, and the adjacent is the A. All right, so x over this. So negative 1/4, 1 divided by x over the square root of 16 minus x squared. And when you divide by a fraction, it's the same thing as invert and multiply. So we get negative of the square root of 16 minus x squared over 4x plus a constant. That is all done. Whew. See, it's like magic. It just worked all out. It's just, these problems have always amazed me. Now, one thing that happens quite often is this. A lot of times at this very last step, people get mixed up. And, they look at the tangent and they're like, x over 4. So do all this work. And they got the negative 1/4 out in front, and then they take the tangent and it's reciprocal. And so they'll do like x over 4 or something like that plus a constant. And then that's their final answer. They go, okay, this is negative 1/16 of x plus a constant. What is clearly wrong with that as an answer? I mean, don't say that, oh, it's just too simple. I mean, give me a little bit more detail. What's wrong with this as an answer? Why is that too simple? Yeah, perfect. If you take the derivative of this, are you going to get anything close to this? Remember, that's what the integral is. It's going to give you an antiderivative. It's giving you something that you can differentiate to get this. And if you look back at that and in your mind at least start to differentiate it, if it doesn't look like it's going to give you this, maybe you want to take a more careful look at your problem, because the derivative of this should give you that. Now, it's a long process to differentiate this and clean it up, but it's doable. And I think I'd be surprised if anyone did that on an exam, but you should be able to do that. Theoretically, you should be able to differentiate this and get what we started with. So, but this looks more reasonable. My message to you is be critical of your answers. Don't just finish up and go, oh, phew, thank God. All right? Take a look back and make sure that your answer makes sense, because you should be able to differentiate this and get what you started with. Okay, anything about problem number 6 here? Easy? Yeah? Okay. All right. Don't wake up. There you go. Thank you. Let's try problem number 12. Bless you. The integral of x cubed dx over the square root of x squared minus 25. And I think that's it. Okay. Again, let's go back to all our various substitutions. Now, don't shout out the answer, but see if you can agree between you and your neighbor which substitution you should use. So what substitution should we use here? Let's see about this. Okay. So it's definitely not number 2, right? Because you don't have a plus here. The difference in this one is the order of the variable and the constant. So yeah, we want to pick number 3. We're going to have a secant problem. Instead of a u, we've got an x. And instead of an a, what are we going to have? 5. Because 5 squared gives me this. So our substitution is going to be x equals 5 secant of theta. Let's let the magic begin. Let's start with dx. What would dx equal? What's the derivative of secant? Secant tangent. Good. So 5 secant theta, tangent of theta, d theta. All right. Looks good. Let's also draw our triangle here. Try and make sure that, we picked the right one. Okay, so here's theta. So secant of theta is x over 5. Secant of theta equals x over 5. I'm going to take a shortcut here. Don't try this at home. I'm a professional. What's the reciprocal of secant? Cosine. All right, so if I take the reciprocal of both sides, I'll get cosine of theta equals 5 over x. And that's a little bit more easy to work with because we're more familiar with cosine. So let's stick with that. Cosine of theta is 5 over x. Let's label some sides here. Vang, what can I start out with? Cosine of theta, so katoa. So where would I put the 5? Here, here, here. This side, or is it A, B, or C? Which one? Yeah, this one. So it'd be 5, the adjacent side. And then what else can I label? Hypotenuse, which should be x. So let's figure out what this side is going to be. Yeah, you're going to get 5 squared plus b squared equals x squared, or b squared equals x squared minus 25. B equals the square root of x squared minus 25. So, wow. The nice thing is that this matches this. That's a good double check of your work.
Does your always match?
Always.
Okay.
If it doesn't match, it's kind of suggesting that you made a mistake setting up your triangle or that you chose the wrong substitution. All right, but they should always match. So this right here and that right there. All right, so let me label that. And then we're going to leave this alone until the end of the problem. But I guess I like doing it here because at least it's the first of a double check. Okay. Let's go through with all the substitutions then. X is 5 secant of theta, so I get 5 secant of theta cubed. Dx is 5 secant of theta times tangent of theta, d theta. In the denominator, I'll get x, which is 5 secant of theta squared minus 25. And again, we're going to get a lot of simplification here. So it kind of depends on you and how fast you want to do things. But I'll get a 5 cubed from here and a 5 here. Basically, I'll get 5 to the 4th power, or 625. Secant cubed. Secant of theta. Tangent of theta. D theta. In the denominator, we're going to do the same thing that we did with the last one. It's just going to look a little different. That's going to be square root of 25 times the square root of secant squared of theta minus 1. There's some more simplification I can do in both the numerator and denominator. I'll give you a chance to catch up with your writing and shake your hand loose, because this one's getting long. Okay. Secant cubed times secant is going to be a secant to the 4th power. I'm going to get some simplification here. Square root of 25 is going to cancel with one of these. Leaves me 125. I'll take that out in front. 125. Secant to the 4th of theta times the tangent of theta, d theta. What's going to happen in the denominator? What's the square root of secant squared minus 1? Tangent squared. Good. So I'll get the square root of tangent squared of theta. And you see the nice thing that's going to happen now. Square root of tangent squared is tangent. And that's going to cancel out with that one. Wow. Getting better all the time. So that's 125 times secant to the 4th of theta, d theta. Well, how are we going to do this one then? This is good practice from the stuff we did last week. Break it up. All right, let's break it up. What times what? Oh, excellent. Do it all in one step. Nice. This is secant squared times secant squared. But remember, secant squared is 1 plus tangent squared. So 1 plus tangent squared of theta. D theta. All right. Looking more hopeful there. If you need a quick little reminder here, let me remind you on how to come up with these identities in a pinch if you need to. So let me just do that over here. It all starts with the basic identity of sine squared of theta plus cosine squared of theta equals 1. For trigonometric functions that have a cosine in the denominator, divide everything through by cosine squared. And that gives me tangent squared of theta plus 1 equals secant squared of theta. And then if I needed to, I could move the 1 to the other side, or the secant squared over here, or both, whatever. But in this case, secant squared times secant squared is essentially what we have. Looking better. Now what? Use substitution. basically what we did here is we split off our u substitution, our du term. Because if u equals the tangent of theta, what's du going to equal? Secant squared theta d theta. Secant squared of theta d theta. Thanks, gentlemen. Okay. That's 125 times the integral of 1 plus u squared du. Yay! See? Here's the easy part, right? Integrating that. 125. Oops. I don't need that. Never happened. Photoshop. Thank you. 125 times u plus u cubed over 3 plus a constant. Now we got to unravel this a couple times, right? First, starting with our u substitution. So that's going to be 125 times tangent of theta plus tangent cubed of theta over 3. And then we're going to have to unravel it one more time because we need to figure out what the tangent of theta is. Now, I can kind of see what's going to happen here, so let me suggest we do this. Let's factor out one of these tangent of thetas here. So in addition to the 125 I have out front, I'm going to factor out a tangent of theta. That's going to leave behind 1 plus 1/3 tangent squared of theta. Just kind of looking ahead to something that I see might help us out. Well, I need to figure out what tangent of theta is. So to figure out what tangent of theta, we got to go all the way back to the beginning. Parth, what's tangent of theta going to equal, please? Good. This over this, opposite over adjacent. So let's put that in all the right places. So that's going to be the square root of x squared minus 25 over 5 times 1 plus 1/3 times the square root of x squared minus 25 over 5 squared. And at least having factored this out, this is going to simplify this term a little bit nicer. I'll end up with 125 times square root of x squared minus 25 over 5 times 1 plus 1/3 x squared minus 25 over 25 plus a constant. And of course you can combine that as over 75 if you'd like. That's fine. I'm most concerned that you get down to something like this. The exact form doesn't really matter to me too much. It's a little bit more challenging to grade these kinds of problems because there is a little bit of wiggle room as to how you write the final answer. The important parts are to get all the substitutions right, to get this kind of term when you're all done. And other than writing that as over 75, I think that's pretty much all we can do here. Please.
In the beginning, we chose a formula. We chose u squared minus a squared. Can we have chose a squared minus u squared and take out a negative?
No, because you're not going to add, it's going to be hard to factor out the negative from the square root. Because that would require an imaginary number. Yeah, and you can't, yeah. So I think you're kind of stuck with just this one choice here on this one. Yeah. But if you make the right choice, these things work out. That's why I started out the trick with they're just magic. They just work out. It's really cool. Anything else on problem number 12 here? This trick works for the problems with those special square roots. That's where it works the best. Yeah. Yes.
You said there were only going to be two that you were concerned yourself with?
You.
Or we should practice all three?
We'll get around to practicing all three. Yeah, but it's not as if you have to memorize the formulas in great detail. Right? Let's take a look at problem number 24. So the integral of 1 over the square root of x squared minus 4 dx. What is it tempting to say? What does this one look like? You say, oh, it's just begging for something. It's not quite there, but yeah, it looks like the arc sign, doesn't it? Why isn't it the arc sign? Yeah, the number's in the wrong spot. It would be 4 minus x squared. That would give you your arc sign. So, well, let's take a look at our substitutions again. Decide which one we want. Which one's going to work for us? Yeah, 3. Third one. A equals, or in our case, we'll have an x squared here, so x will equal a secant of theta, so 2 secant of theta. That's what we're going to end up with. X equals 2 secant of theta. Dx. What's the derivative of secant of theta? Secant times tangent. Secant tangent. So 2 secant of theta, tangent of theta, d theta. Should we take time out to draw our little triangle? Make sure it works? I think it's a good idea. Because if your triangle doesn't have a side that matches this, there's something wrong. So let's do that. I'll rewrite the theta. Can you suggest another way to rewrite this? Equals cosine of theta. Don't tell my trig students next semester that I did this. I don't know, I'd probably catch some grief about it. All right. All right. Here's theta. Try and label the sides. Try and do this one for yourself. So cosine is adjacent over hypotenuse, so 2 and x. And if you play around a little bit, you're going to get the square root of x squared minus 4 here. So we do get the nice match that we're looking for, which is this here and that there. So it's a nice double check of our work. Let's proceed with the substitution. dx is 2 secant theta d theta, or tangent theta d theta. So I'll put that up top. 2 secant of theta, tangent of theta, d theta, over the square root of 2 secant of theta squared minus 4. So as usual, we're going to get some nice simplification from this. 2 secant of theta, tangent of theta, secant squared of theta minus 1 because I'm factoring out the 4. So I'm going to get some nice simplification here. 2 secant of theta, tangent of theta, d theta. How's the denominator simplify?
2 cancels out, and also the secant like that section would be tangent.
Yeah, so this turns into a tangent squared. Square root of tangent squared is just tangent. And then that'll cancel, and the 2's cancel. So, wow. All right, time to scratch your brain a little bit. Secant of theta does have a nice antiderivative. Go ahead. Well done. Natural log of secant theta plus tangent of theta. We're not quite done. We've got to substitute in the expressions for secant of theta and tangent of theta. So, what's the secant of theta going to be? X over 2. That one's actually already done for us right here, right? So that's x over 2. Plus tangent of theta is opposite over adjacent, so square root of x squared minus 4 over 2. Nice. And that's it. Just, yeah, wait.
That was easy.
Yeah, all right. Maybe not. Yeah, it was the easiest one. Relatively easy would probably be, yeah, I need a new button. That was relatively easy. All right. Are these getting a little bit better? I mean, they just work. Just always was amazed by this section.
So by doing this, you don't have to memorize all the formulas in the apex?
No, I would never make you memorize all the formulas in the appendix. Yeah, it's just deriving some of these things. I mean, you can use this. For instance, this technique will help you derive certain rules. I mean, there's special integration formulas that are part of Theorem 8.2. But you can derive these by doing what we're doing now. This kind of stuff. So, no. There's so much to memorize. And of course, once you get out of this class, once you're in the workplace or something like that, you can look up the stuff all day. So I want you to know how to set it up. I want you to know some of the basic ones, but I don't want to try and give you something that's really off the wall. You need to understand a lot of the underlying concepts, and that's what I'm looking for. Yes? Well, what happens is that by transforming it in this way, you get the integral of some trig functions, and those trig functions, generally speaking, will simplify down to something that we can integrate. And once we integrate it and have it in the form of a trig function, then it's a matter of going back and saying, all right, well, this is a secant of theta. All right, so that would be x over 2, hypotenuse over adjacent. And this is the tangent of theta, opposite over adjacent. And just finishing it up, putting it back in terms of the original variable. Now, once again, take a look at our result here. I mean, it's hard to think about all the work that would take, but if you differentiated this, at least I've got a square root term here that, you know, could conceivably lead to something down here. All right, it'd probably take an awful lot of work to simplify it like that, but at least that one's here. If you didn't have a square root term here, then you should say, uh-oh, there's something wrong. Because if there's no square root term here, then how are you going to get one when you differentiate it? It's just not going to pop out of thin air. So again, I'm suggesting that you be critical of your answers and look back. All right. Let's try one last one here. Problem number 22. The integral of x squared over the square root of 36 minus x squared. Now let me at least get you a little bit of a head start without necessarily cracking out my book. Let's see, it needs to be a dx here. Because of the form of this, we're going to use x equals 6 sine theta. So that's your little head start. See if you can't finish this one up. Let me give you a little reminder here as you work your way through the problems. last week we introduced some power reduction formulas. And I'll give you one more reminder. Sine of 2 theta is 2 times the sine of theta times the cosine of theta. So a couple little reminders here as you finish up the problem. This is squared. Dx is just this. So you should have this right here. 6 cosine of theta. Oh, it's x squared. Well, the x squared, this is x. So you get the sine, 6 sine of theta squared. Right? But you've got that. What you're missing is this part. 6 cosine of theta.
So you have both.
Yeah. Because you're replacing not only x squared, but you're replacing dx. Replacing one and then the other.
Oh, so you put both of them work.
Both of them. Okay. This is squared. So squared is x. So cancel. Just do that squared. will cancel to 36, so we integrated 1 minus cosine of theta. And that's going to make it.
Instead of cosine squared, we use no, this is cosine. This is correct. I think when you copy it over, you made a typo. You gotta do it.
So you get a theta, and you get a plus or minus.
Angle. Well, just factor out the 36. 1 minus sine squared theta is cosine squared theta. Is no more negative. No more 1. Right? I think you skip steps, so that's
We'll
all.
have to do an arc sign to get theta by itself.
So it's good. So 6 and 36
You're going to have to
cosine
go
of
back
squared
to here,
cancel.
theta. So there is. So this is cosine. Right?
It's gone.
Just follow this.
Yeah, it's cosine.
No, because when you use our thing,
Yeah, you skip steps, so it's okay. It's good that you skip steps. It's gonna be you're getting more complicated.
I mean, you're close. There's a constant that's also close.
so it'll just be
As I go
sine.
through it, hopefully you can find it. Well, you got to integrate that first, so it becomes.
Oh no, I factored it out.
Actually,
Good. So you cancel the 6 touch here.
cancellation. Looks like you've done two.
Yeah.
Did you integrated this and apply that formula all at once?
Right, you square the 6 first. 6.
So,
You miss. Do it again.
so I'm not sure we got this. You, they don't know. Yeah, no. From here to here.
Yeah, I'm not sure that you, I don't know if you can get that.
But this is, you're not going to integrate this with the use substitution. Just, now, I don't know if that's your theta or not. So when you integrate that, you're going to get theta minus 1/2 cosine, or 1/2 of the sine of 2 theta.
Okay, I'm just watching.
Okay, all right. But you're getting close. All right. Woohoo! All right, so the mother of all little pauses here. Let's see where we're at. Okay, so let's unravel this one, and I'm glad to give you a chance to work on it. But let's see what we can find. We agreed that we're going to do x equals 6 sine of theta. That means dx is 6 cosine of theta d theta. Now there's two things that we're going to have to eventually substitute into our integrand. We're going to have to replace the x, well, we got that substitution here, but we're also going to have to replace dx. So dx is this right here, 6 cosine of theta, d theta. So that's my dx. Here's my x squared right here. And then square root of 36 minus x squared, so that's 36 minus 6 sine of theta squared. All right. So there's all our replacements. Let's just double check that we picked the right substitution. So if I rewrite that, that's x over 6 equals a sine of theta. Sine of theta is opposite over hypotenuse, so x and 6. From the Pythagorean theorem, you can show yourself, and you should take the time to do it carefully, that you get the square root of 36 minus x squared down here. Now, let's keep track of all the 6's. 6 squared is 36. 36 times 6 is 216. So 216 sine squared cosine of theta d theta. Over, well, that's going to be a 36. Squared is going to be a 36. I'm going to factor out that 36. That's going to leave behind 1 minus sine squared of theta. What happens to sine squared of theta? Cosine squared of theta. So 6 into 216 will cancel. Cosine squared of theta square root of cosine squared of theta becomes cosine of theta. This term and this term are going to cancel each other out. This eventually becomes cosine of theta. That cancels out with your cosine of theta there. So all that's left is 36 sine squared of theta d theta. Now I gave you a little reminder that sine squared of theta is 1 minus cosine of 2 theta over 2. These are your power reduction problems or power reduction formulas from last week. The 2 and the 36 cancel. That gives me 18 times the integral of 1 minus cosine of 2 theta d theta. We can find the antiderivative of the first part pretty easy, right? Antiderivative of theta, or excuse me, of 1 is just theta. Minus. Now, the antiderivative of cosine of theta, cosine of 2 theta, is going to be a sine of 2 theta somehow. But there's this constant that we have to deal with. Are we going to end up multiplying by that 2 or dividing by that 2? Dividing by that 2. So divided by 2. Let me pause. We okay up to here? Now there was one last little trick that I told you. I reminded you that sine of 2 theta, there's a double angle formula, so that's theta plus, theta minus 2 sine of theta cosine of theta. That's your double angle formula. And very nicely and neatly, the 2's cancel out. 18 of theta minus sine of theta cosine of theta plus a constant. Almost done. First things first, I need to figure out how to get theta by itself. And I saw a couple of you do it. I was very happy to see that. To do that, we can go all the way back here to x over 6 equals sine of theta. How would you get theta by itself? Yeah, the inverse sine. Arc sine, inverse sine, same thing. So the first part is, rats. 18 times the arc sine of x over 6 minus the sine of theta. So sine of theta would be x over 6. And cosine of theta is square root of 36 minus x squared over 6. Square root of 36 minus x squared over 6. Again, I think we're going to leave it right here. It's about as far as I want to go with this one. I really don't see that there's much more we can do other than 6 times 6 is 36. Whew. Okay. Are there any details here that are still missing in your mind? Something that maybe I went over a little too fast. That enabled us to break up sine of 2 theta into 2 sine of theta cosine of theta, so that we had some terms that we could deal with. Because otherwise, you'd really struggle to find the sine of 2 theta. We don't have a triangle for 2 theta. All we have a triangle for is theta.
Can we substitute in theta after we solve for it? Oh, I guess that would get really
Yeah, I would strongly suggest you do it this way. I mean, there might be another way to do this, but I think that this is the most straightforward. So, you know, the couple reminder formulas. I mean, one we did last week anyways, right, was this one. So the reminder formula that I gave you was this one right here. Sine of 2 theta is to sine of theta, cosine of theta. Anything else? Appreciate the questions. For homework, try 1 through 31.